Okay, so guys, good evening. Is is my voice clear enough?
Yes, sir.
Okay, and the screen is visible to you all?
Yes,
Yes,
yes.
sir.
Okay, so we will start with the mock session today. I assume that you all have tried it. Okay, so let's start with the very first question.
Sir, could you zoom it a bit?
Is it fine now?
Yes, sir. It's fine. Thank you.
Okay, wait a second. Okay, so for the first question we have got the OneNote is visible to you all, na?
Yes.
Okay, so
Yes, sir.
Manoj and his brother Nitin have five friends each. Okay, and Manoj's friends circle has two boys and three girls. So Manoj uh, has two boys friends, two guy friends, and three girls friends. Okay, and Nitin has a friend circle of three boys and two girls. For their parent wedding anniversary, they decide to invite four of their friends. So both of them, Manoj, plus Nitin, will invite four friends. To ensure equal representation, it was decided both of them will invite two of their friends and also ensure that there are total of two boys and two girls invited. Okay, so Manoj can invite two of his friends and Nitin can invite two of his friends. Okay, now one more constraint we got is there should be two boys at least and two girls. So
Sir,
this kind
the value of NC0 is 1. No.
value of NC zero. Yeah, the zero is equal to one. Why you are asking this,
Oh,
by the way?
this question will take this
Yeah,
information.
okay, so two girls and two boys here. Okay, so we have to make cases now. The case first will be we got Manoj as M and Nitin as N. Okay, so Manoj will invite two boys and Nitin will
First
invite
case.
two. First case, two girls. And how many ways we can do that?
Three ways.
Two. Manoj will take
2C2
two C2
into
and
2C2.
Nitin got three. Sorry, yeah, Nitin got two girls and he has to invite two girls into two C2.
2C2.
And
Yes,
similarly,
sir.
Manoj got two boys and he have to invite two boys. Okay. In this many ways,
Equal to 1.
we can invite for for case one in type case one. For case two, we got now Manoj can invite two girls and Nitin can invite two boys. Okay. So Manoj has got three girls friends. So three female friends. So three C2 into Nitin has got three guy friends. So three C2. And this will be
9.
uh,
9.
nine. This will be nine.
And
Case
case
three.
3 is one boy and girl from Manoj's friend.
Yeah. Who is this? Divya.
Hmm.
Yes. I really appreciate you know the solution, but stop interpreting in between. Okay. Maybe the other will get confused. Okay. Uh, okay. So if we can start. One guy. As Divya was saying. In case three, we get Manoj can invite one guy, girl, one female friend, and one male friend. Similarly, Nitin can invite one female friend and one male friend. Okay. And how many ways we can do this? Manoj got two balls, so 2C1 into 3C1. Similarly for the in Nitin case, 2C1 into 3C1, and in total we get, I think we will get 2 into 3 into 2 into 3, 6
36.
into 6, 36. So on adding all these cases, we will get 46, and that's the answer. Divya, this is what you got as your answer?
Yeah.
Okay, nice. Now we will move to the second question.
In the first and second case, we also add that C2C0 in the
Yeah,
second
like
case.
we didn't write it here, but you can write it like
Hmm.
out of three
Out
girls,
of
we are choosing zero,
0.
and that will simply be one. That's why we are not writing it here. Okay. Now, in case you can see the question, you all can see the question number two.
Yes, sir.
Okay. A group of 5 employees, 3 leaders want to do a group meeting. They have decided to sit around a circular table. Okay, such that all leaders will sit together. Find a number of ways in which employees can sit around a circular table such that all leaders will sit together. Okay, so we have got 5 employees. One, two, three, four, and five. Okay. And now we have got 3 leaders, but what constraint we have got? All of them should be sitting together. So what we will do, we will treat these three as a single entity. So around a circular table, how many entities we have got? In total of 5 employees and one this entity. So in total we have got 6 entities around the circular table, and the number of ways in which we can arrange these 6 people around a circular table is n minus 1 factorial. We study this in circular permutation. So that simply will be
Yes.
6 minus 1 factorial, 5 factorial. And now for the internal arrangement of this, and what do I mean by internal arrangement? Like we have got this entity, leader 1, leader 2, and leader 3. They can change seat within themselves, and then
Sir,
yeah,
fi-
Divya.
5 employees. How can you take 6?
See, there is this 5 employee. Okay, and then we have got this one three. We got 3 more leaders now, and they need to be sit together. So what we are doing, we are taking these 3 leaders as a single entity. Okay, so we have got this entity and then 5 employees. Got it?
Yeah, sir, got it.
Okay, and now what we are doing, we will multiply this 5 factorial into 3 factorial. Why this 3 factorial? Because of the internal arrangement. And what do I mean by that is, like we are treating this as a single entity, but within them, the constraint we have that leader 1, leader 2, and leader 3 should sit together. So either they can do in this way or they can do this in this way. In total, there will be internal arrangement in between them. That's why we are multiplying 3 factorial to it. And in total, we will get what this calculation will get us
720.
720. We will get 720 as our answer. That's the first option. Okay.
Sir,
Yeah, Renu.
sir, once again explain the concept, sir. I can't able to get it.
Okay, okay, just wait. So basically, in this question, what they are saying, we have got 5 employees and 3 leaders. Now we got 2 constraints. Now, we have got only one constraint that the the leaders should be together on the circular table. What together means? They should be around each other, like L1, L2, L3 should sit together. So to meet this constraint, what we are doing, we are tying this all three together and treating this as one single entity. One single entity, okay? Now, so we have got 5 employees and one this entity. So in total, we have got six entities to arrange around the circular table. So we have got these employees and one group of these leaders. Now we studied in the circular permutation part that to arrange n number of people around a circular table where clockwise and anticlockwise are different will be n minus 1 factorial. Got So we have got 6 entity in total, and we have to arrange them around this circular table. And here permutation, and here anti-clockwise and clockwise are different. So we can arrange them in 6 minus 1 factorial way. That will be 5 factorial ways. Now, this single entity, which we are treating as one, is a group of 3 people. And the constraint we have got is they should sit together. But they can sit together in like this way. Then uh, the leader 1 and leader 3 can sit their places. So in total, we have got 3 places and we got 3 leaders. Okay, Rosni, after this question, we will get back to the first question again. Okay. So in this way, we have got 3 places and 3 leaders. So we can arrange them in 3 factorial ways. That's why for the internal arrangement of these group of leaders, we are multiplying this to 3 factorial 2. Okay. Then altogether we will get 720 permutations. Okay. Got it, Renu? Or you are still confused?
No, sir, I got it.
Okay, so let's switch to the first
Uh,
question.
Hello.
Yeah, sorry, yeah.
What is the formula of object can be arranged in a circle?
The formula to arrange n entities around a circular table where anti-clockwise and clockwise are different is n minus 1 factorial, okay? And where anti-clockwise and clockwise are same will be n minus 1 factorial by 2, okay?
If
And 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 people around.
Sir, but the
Okay.
question is asking how can we arrange the employees, not the
No, the question they're asking which employees can sit in how many ways employees can sit around a circular table so that all leader will sit together. So
so the
in the
5 employees of 5 factorial 120 was,
fi-
I think.
5 employees, like first of all, you are applying 5 factorial. Even if you do this way, like we are just have to arrange 5 factorial. But if you go through the question again, in which employee can sit around a circular table such that all leader will sit together. So they are including leaders in the employee. Okay, and then you are asking 5 places, and you have got just 5 factorial. You are doing this for normal permutation, but here we have got circular permutation. That's why this will be wrong. And again, we haven't got just 5 employees. We have one group of leaders too. You have to arrange job. It's not saying just how many of the employee can sit together. The leaders will sit together with them too. So in total, we will get 5 plus 3, 8 people. But because of this constraint, we have to treat these 3 people as a single entity. So we got 6 entities in total. Okay.
Excuse me, sir.
Yeah.
Sir, what if in the question it was asked they shouldn't sit together? Then how we would
They
have done it?
shouldn't sit together if they have asked like this. What we will do, these are the way, like 720 is the way in which 3 leaders will sit, in these permutation, 3 leaders will sit together. Yes or no?
Yes, sir.
Now, in how many ways we can arrange 8 people? 8 people around a circular table. That will be 8 minus 1 factorial. That will be 7 factorial.
Yes, sir.
Now, when we subtract 720 from this 7 factorial, we will get all number of ways in which these 3 leaders will not sit together. Okay.
Excuse me, sir. When to apply the formula n minus 1 factorial by 2?
Like we have got this circular table. Okay. Let's say we have got A here, B here, and C here. When in the question is saying, let's draw the mirror image to this, then C will be here, A and B is here. Then when this is basically this is referred as clockwise and this is referred as anti-clockwise, either one of it. Okay. When the quotient is given that this is same, then you have to use this formula. When this is not same, these both are different. When these both are different, we have to use this formula simply. Okay.
Okay.
Sir, one doubt, sir. Why can't we use only 7 factorial if they don't sit together, sir? 3 will not sit together.
We can't use 7 factorial because in this 7 factorial ways, the total number of ways, this 8 people, this 8 people can be arranged on a circular table. You're getting my point? We have got like what we are doing here. We are taking 5 employees plus 3 leaders, and we are arranging them on a circular table. So this will include all those ways where these 3 leaders are sitting together and are not sitting together. These will involve all those ways. So we have to subtract the ways in which these 3 leaders are sitting together to get all those ways in which these 3 leaders will not sit together. If the question was like this, in how many ways? In how many ways 8 people can sit on a circular table, then it will be 7 factorial. Okay.
Okay,
That's
sir. Thank you.
8 minus 1, that will be 7 factorial.
Sir, but it didn't mention that it is clockwise and anti-clockwise are same or different.
So this,
How to determine it?
okay, just wait a minute. Let me plug in my laptop. Okay. Okay, so what is your doubt, Chetan?
How to determine whether the clockwise and anti-clockwise are same and
Like
different?
one, you have to derive that from the context of the question. Like I solved one such question where it was given like that. Like B should B or where B and C should just sit next to A. It doesn't matter in which order. Like here, B and A are B is next to A and C is next to A. In the similar permutation, this is even here, B is next to and C is next to A. So in this, when this is given in the question, then you have to assume that these are similar. In this question, what they have given? 5 employees and 3 leaders. So let's get this is the first employee, and we got 3 leaders here, and then second employee. This will be different to this. Basically, when nothing is given in the context, nothing different is given, you should consider only normal permutation where anti-clockwise and clockwise are different. But when there is something given on how, like, if it doesn't matter if C sit on the left of A or C sit on the right of A, that's we should treat that's same. Okay, then anti-clockwise and clockwise are similar. Okay, so basically you have to go through, like, you have to understand that from the context of the question only. There's like sometime in simple question they will give that clockwise anti-clockwise doesn't matter, but most of the question you have to interpret that from the question. Okay.
Okay.
Sir, one question here. This -1, assuming you have this 3 people sitting anywhere, that condition, instead of sitting in one place, they are able to sit in any place they like. But you have subtracted from 8 factorial, that is, sorry, 8 minus 1 factorial, you subtracted the number 120. So I'm not clear how you got
Sorry,
that one.
like you're asking basically how we got this one.
No, n-1 is clear that 8
Okay.
people sitting around the table, 8 minus 1 is 7. But after that, you have removed a certain.
720. 720.
So
Okay.
can you explain why that 720?
See, if like the question was like this, in how many ways we can arrange 8 people around a circular table? Okay.
Right.
So that will be 7 factorial.
Yeah,
And
that part is clear.
And that will include all the ways in which these 3 leaders are sitting together and these
Correct.
3 leaders are not sitting together.
Yes.
Like in this 7 factorial ways, there will be ways in which these three leaders are sitting together,
Correct.
and there are ways in which these three leaders are not sitting together. And
Correct.
the question what somebody asked is,
Yeah.
in how many ways these three leaders will not be sitting together?
Okay, not sitting
So
together. Okay, we have to
okay, so
subtract from that
so
the number of
this include in which, okay, just it leaders
Hmm.
leaders are sitting together plus leaders are not sitting together. Okay, this 7 factorial ways. Now
Correct.
we need to find this. Leaders are not sitting together. So we need to subtract this entity from this 7 factorial ways.
Uh-huh.
So that's why the in number of ways these leaders are sitting together is 720, which we just calculated for this question.
Right.
So that's why we subtracted this. Okay.
Okay.
Sir, can you go through the first question?
Yeah.
Sir,
What's your doubt?
do it, sir, quickly, sir.
Yeah. So what's your doubt in this topic?
Sir, actually, I didn't understand the cases.
Yes, yes, okay. So in this question, what we have, Manoj has got 5 friends with this distribution. Nitin has got 5 friends with this distribution. Now they have to invite 4 friends. In total they can invite 4 friends for their wedding. So what they decided to constrain that both will invite two friends, and to maintain the representation, they should focus that they will invite 2 boys in total and 2 girls in total. Okay. Now
sir.
we have to make cases. So the maximum number of friends Manoj can invite is 2, and Nitin can invite is 2. Now case 1, and this now we have to match this constraint to, we have to invite 2 boys and 2 girls. So in the first case, Manoj will invite all the boys and Nitin will invite all the girls. Okay. And the next case, Manoj will invite 2 girls and Nitin will invite 2 boys. And for the last case, both will invite 1 girls and 1 boy. And in these cases, these two constraints that Manoj and Nitin will invite 2 of their friends, 2 friends each, and we get 2 boys and 2 girls in total will met. Okay. These two constraints, and only these 3 cases are possible for these two constraints. Okay.
Okay, sir. Thank you.
Okay, so now we can move to question number 3.
Sir,
Yeah.
sir, I can't clear with in which case we want to use permutations and which case we want to use combinations. Can you explain this case, sir?
Permutation is permutation where case the basically arrangement is not required. No, sorry, arrangement is required. Like arrangement is important. Let's say we have got 3 people. Okay, first people, second people, and third. Okay, now you will use permutation when 1, 2, 3 is not similar as 2 and 3. Like see, here we have got only these 3 people. Let's say, but the way they are arranged is different. And in combination, what we use, like we just have to choose people. Like we got 4 people and we have to choose 3 of them. So either you choose 1 first, 2 first, or 3 first. That will be similar. That will be similar to choosing 3 first, or 2 first, or 1 first. Basically, when arrangement is important, use permutation, and when arrangement is not important, use combination. Okay.
Sir, with respect to the question 1, you had 3 cases.
I
So
had three.
the results of the 3 cases have to be added, right?
Yeah, we added in like 1 plus 9 plus 36, and in total we got 46.
Oh, okay, right. Okay.
Aryan, you got your doubt cleared, or you are still confused?
No, sir, I can't able to understand where we need to use permutations.
Okay, so let's first solve the mock questions, then we will
Where the
explain.
order is important, we have to use permutation.
Yeah, in simple way, but okay, just wait for you at the end. We will discuss these doubts in the last. Okay. For now,
Okay, sir.
we are switching to the Third question. Third question is visible to you all?
Yes, sir.
Okay, for the
Can you
third
zoom
question.
it?
Yes, sir.
Now it's fine.
Yes, sir. Thank you.
Okay, so Kanika has to choose t-shirt for her outfit from a collection of 6 yellow, 2 black, and 4 blue. If a shirt is chosen randomly, then what is the chance that a black or a blue t-shirt is chosen by Kanika for her outfit? So they are basically asking, like, let's say, why is the event of choosing a yellow shirt to black? BL is the event of choosing a black shirt, and B is event of choosing a blue shirt. Okay, so they are basically asking, what is the chance that a black or blue, a black union blue shirt is chosen? So in simply, how many black and blue shirt in total? We have got 2 black shirt and 4 blue shirts. 2 plus 4 by total number of shirt we have got 6 plus 6, that will be 12. Simply 0.5 will be the probability. Everyone got this?
Yes, sir, got it.
The question 4 is visible to you all.
Yes, sir.
Yes, sir.
A fair dice is rolled twice and a fair coin is tossed twice. Define event A. 3 appear on the dice twice, and B. A head appear on the coin twice. Okay. So A is we rolled a dice twice. So how many outcomes we can get? 1 1 till 1 6, then 2 1 till 2 6. Similarly 6 1 till 6 6. So in total we will get 36 outcomes, 36 possible outcomes.
Yes, sir.
And what A is? 3 appeared on the die twice. So basically, what is the probability of this? This will occur only one single time. So the probability for this is 1 by 36. Everyone?
Yes, sir.
Now what event B is?
No,
B,
sir, here is the confusion.
okay,
How
so
can it be the 36 in the A set?
okay, how you you calculate the probability? Total number of
Favorable outcome by total outcome, total possibilities.
total possibility. So we got 1 1 here,
Hmm.
then got 1 2 here, then got 1 3, 1 4, and 1 5, and 1 6. Okay.
We are using 2 dice or two or a
2
single
dice.
die.
2 dice, 2 dice. We are using a single dice, but we are like rolling it twice. So simply 2 dice. Okay, we can treat this as 2 dice. We are rolling 2 dice. We can treat this as like,
The
okay.
probability can be 1 by 6 into 1 by 6, na?
Why 1 by 6, 1 by 6? We have got 6 outcome for the very
Because
first.
when first we throw the die, then the probability of coming 3 is 1 by 6. because there is 6 possibilities. 1 can come, 2
So
can
you are
come, 3
saying
can
you
come, 4
can
can
say
come.
1/6, 1/6. That's
Hmm.
now.
Hmm.
That will be 1/36 only again.
Yeah.
And if you even do that way, this will be 1/36 only. Okay, got it?
Okay. Hmm.
Now for the event B, we are tossing two coins. So what outcomes we can get? We can get tails, head, tails, tails, then head, tails, and head, head. And B is defined as a head appear on the coin twice. So again, we have got only one such outcome. The probability of
It's
head,
1 by
head,
4, sir.
1/4. Now, like you know what's an independent event is?
PA into PB.
So
So it will
if
be 1.144. 144, sir.
yeah, so like if you look after this question, you will see the event B and event A is independent. Like the occurring of A doesn't affect the occurring of B, and similarly, and the vice versa. Okay, so basically these both are independent event, and we have studied this formula for independent event that for two independent event, the probability of A intersection B is simply PA into PB. So PA we have got 1/36 and PB we have got 1/4. So in calculating what we are getting
1/144.
1/144. So I think D is our answer. Okay, everyone got this?
So just little bit scroll up. Just hold on. So hold on in this.
Okay, okay.
I need to write something in the upper portion of this question.
Right.
Just go. Just here.
Okay, the recording is available, so you can, if you are taking notes, you can do it
So
on your.
basically, these are disjoint events.
These are
Disjoint events.
okay. Disjoint events and independence events are different. Disjoint events basically mean there is no intersection part.
Okay.
This, but here is obviously intersection. That's why we are calculating independence. So
Sir, once
Okay.
explain a difference between disjoint and loop.
uh, this is simply that what a independent event basically is. We got PA given PB. Okay. Let's say in this question, in context of this question, if we toss a coin, let's say if we toss the coin twice and we got tail head. Okay, tail head. Now will it affect the outcome of A? After getting this result, we will now roll two dice. Will it affect the outcome of this?
No, sir.
So
No,
that's
sir.
why simply even after B occurred, the probability of A will this given B is simply equal to PA.
Yes, sir.
That's what disjoint means. Disjoint. So that's what I'm saying. That's what the independent event is. And then how we got this formula. So this formula by conditional probability we get like this: P A intersection V by PB. Now this PA given B is simply PA. We got PA into PV is equal to PA intersection B. This we got from conditional probability formula. And on putting this value into this, we will get this formula. And what disjoint event is basically, there's no, we got event A and event B. The set A intersection B is a null set. This is what disjoint set is. Disjoint events are. Okay.
Thank you, sir.
They
Excuse
both
me,
are
sir.
disjoint also, sir, na?
Both are?
Both are disjoint also.
No, the independence events need not to like even obviously there is intersection. That's why we are calculating the probability of intersection part. So they are not disjoint.
Excuse me, sir.
Yeah, Vaishnavi.
Sir, if we add simultaneously in that question, will it become dependent?
We act simultaneously. Uh, like, what do you mind with simultaneously? We rolled two first a dice, then again a dice, then a tails, and then a toss the coin, then again toss the coin. That's what we did. Like, not getting your doubt, sorry.
Sir,
I
it's
want to.
simultaneous only because and is
Yeah,
there.
yeah, it's simultaneous only. Okay, Vaishnavi.
Yes, sir.
Okay. So any doubt now till in the questions? Any question now? Everyone got it?
Clear, sir.
Clear, sir.
Go to question number 4.
Yeah.
Sir, to access the recording, we have to use the same link from the calendar, or what is the procedure?
I have no idea with it. I think this will get. I think this is on YouTube too, and you will get this on calendar too. So that's what
It is on YouTube.
it is on YouTube too. But
Okay,
yeah, it's
fine.
on YouTube.
Right, thank you.
You can get the link from the calendar.
Okay.
This is the 5th question we have got. Okay. 2 bags B1 B2 contain candies are placed on a table. Bag B1 contain 7 cinnamon and 4 ginger candy, and bag B2 contain 3 cinnamon and 8 ginger. The boxes are arranged such that the probability of selecting bag 1 is 1 by 3. Probability of selecting bag 1 is 1 by 3. And the probability of selecting bag B2 is 2 by 3. Someone is blindfolded and asked to select a candy. She will win a color TV if she selects a cinnamon candy. Based on the given information, answer the following question 9 and 10. What is the probability that someone will win? So when someone will win? Someone will win when she select a cinnamon candy. So basically we have to find the probability of selecting a cinnamon candy. PC. This is what we have to find. Now to finding this, what we will use? We will use the law of total probability. And the law of total probability will fetch us. This will be equal to PB bag 1 intersection C plus B2 intersection C, and this will be probability of bag 1 into probability of C given bag 1 plus probability of B bag 2 into probability of C given bag 2. Okay.
Sir, how can we know to use these formulas?
Basically, they have given what they have given. They have asked for a probability of choosing a cinnamon candy, and we have got 2 events, namely bag 1 and bag 2. And you know, the usually exhaustive event, like so either you will choose from bag 1 or bag 2. If you choose candy, you will choose it from bag 1 or bag 2. So now we have to find the probability this circle C, and half of it, like one part of it lie in B1, one part of it lie on B2. Here we use the law of total probability. In this kind of situations, we use the law of total probability. Okay.
Okay, sir. Thank you.
So this is given to us as 1 by 3, and this we can calculate. In bag 1, there are 7 cinnamon and 4 ginger. That would be in total we have got 11 candies in bag 1, and 7 of those are cinnamon. So this will be the probability that if bag 1 is chosen, and then someone will choose a cinnamon candy. This will be the probability of that. Similarly, B2 it is given to us 2 by 3 into, we have got 8 ginger candies in this and 3 cinnamon candy here. So that will be 3 by 11. And on calculating this, I think we will get 13 by 33. And that's the answer to this question. The last option, D option. Okay. Everyone got it?
Sir, just little bit scroll down, sir. I have to.
Okay,
I'm
wait.
taking notes, sir. Just. Just hold a minute.
Sir, in the formula, can we write it as P of B1 intersection C equals to P of B1 into P of
Go slow. What you are saying? P of B1
intersection C equals
Yeah.
to
equals to
P of B1 into
P of B1 into.
P of B1 given that C.
No, if you want to this use, you have to write. This is not the same. You can do this. P of C given P of C given P of B1 given C. You can do this. There's the multiply. But okay,
Okay, so if we use this formula also, can we get the answers?
you can get the answer, but thing is, the P probability of C is not given to us. That is what we have to calculate. We have to use the formula by which we will get the answer. Yeah, this obviously this is the unknown we have to calculate. That's why we choose to like
Okay, sir, I
according to the
understood.
law of total probability, this into this, and this will be similar to this into this. But obviously, on choosing this part of the formula, we will not get the answer. So that's why we choosing this part. Okay, because
Okay,
this is given to us. This is not.
if we want to find P of B1, then we will use this, no?
Yeah, if we want to find P of B, if yeah, we if, no, if we want to find P of B1, then we will use this first. To find P of C, we use this. To find P of B1, we will use the second. Okay.
Okay.
Okay, so we can move to the sixth question.
Yes, sir.
Sir, proceed further.
Sorry. Sorry. Somebody said something.
You can proceed further, sir.
You can. Okay, proceed further. Okay.
Okay, okay. My voice is a little bit lagging.
Yeah, it was. Now it's fine. Okay, so the sixth question say, if she win a TV, what is the probability that the candy was from bag one? Can anyone give like suggest what the formula we are going to use here?
Sir, Bayes rule.
Yeah, we are using Bayes rule here.
PB1 into PC.
We have to calculate this. That if the cinnamon is chosen, what's the probability that it's from bag one? That simply will be PB1 union C by PB. This is from the conditional probability. Now we already calculated this. Sorry, this is will be C. We already calculated this up there. It's 13 by 33. Now we'll calculate this. That will be PB1 into PC given B1. Okay. We are given PB1, that will be 1 by 3, and we can calculate this. That will be 7 by 11. In bag 1, we have got 7 cinnamon candies and 4 ginger candies. Then 13 by 33. So we'll get 7 by 33 by 13 by 33. This 4 will cancel out, and ultimately we are left with 0.54. Okay. Everyone got this? We use the Bayes theorem here.
Sir, 0.53, sir. 54.
maybe the approximate value, let's see. 7 by 13. It's 0.53846 when we approximate it to 2
Sir,
decimal places.
we can't round off here because when I am rounding up the value, they saying that it's not correct.
So maybe there's wrong with the interval part, but generally you can round this, but okay. If you want, you can write it 0.5. But usually if you round it up to 0.53, it should be correct only. Maybe there is some issue with the interval here, interval given in the question, okay?
There must be a range of answers, sir.
Yeah. Now question number, this was question number 6, no?
Yes.
Sir, your
Question-
voice is too slow.
Okay, now it's fine or not?
No, it's fine.
Okay. So question number 7, now we have solved. Just wait a minute.
Sir,
Yes, Renu?
sir, once again explain, sir. I can't able to understand how you apply the formula and find the answer.
So in this
Explain the
formula, what they are asking, what's the probability that if cinnamon is chosen, like see if someone choose cinnamon and it was from bag B1, and from the base rule we have got this formula P of B1 cross P of C given B1. So basically, okay, let's make according to the conditional probability, what this formula is P B1 intersection PC by PC. Yeah, Renu? This is from conditional probability.
Yes, sir.
Now we already calculated PC and use total probability here. Now for the upper part, we have to calculate how this is equal to this. So now we will expand again this as conditional probability. That will be now this can be written as this using conditional probability. Then like P B1 given C is P intersection C B1 intersection C by P B1. This is again the you can write from conditional probability.
Yes, we can write.
Then you are getting it. Like P, like what we did here. P B1 given C, that would be P B1 intersection PC by PC. Similarly, P C1 given B1 will be P C intersection B1 by probability of B1. And now we simply what we do, we take this to this side and then we will get this formula P C intersection B1 equal to P B1 into P C given B1. And that's what we did here. We expanded this. Like from the base rule, we have got P B1 given C is equal to P B1 intersection C by PC. In down below, we use the law of total probability. And for the numerator, we use this formula and we put this value. This will be equal to PB1 given PC given B1, okay? And we have given this, we can calculate this because the distribution in bag 1 is given to us, that is 4 ginger, or maybe I'm telling there's something like 4 some candy and 7 some candy. Then we can calculate this value PC given B1, and this we calculated in the last question, that is 13 by 33. This is given to us as 1 by 3. So we can use this formula and get the answer. Okay. Then you're getting it. You got it or not? Am I audible, Renu?
Yes, sir.
Did you got it or not? Okay, so we'll proceed further. Now in the question number 7, just wait. The question is visible to you all?
Can roll number started with 0?
Yeah, roll number can start with 0. Like see, roll number roll number password can start with 0 in most of the cases. When you are asked to form digits, then there is this constraint that it should not start with 0. Like you have asked to create a 4-digit number, then it can't start with 0, then it will become a 3-digit number. Okay. So here we have got administration section of university has started to create roll numbers for students following the format 23Z. This is an alphabet 170 using the digits 0 to 6 and capital letters at third position. Assume no digits are repeated. Find the number of ways in which administration section can create a unique roll number. Okay, so we have got this. This will be digit, this will be digit, this will be alphabet, this will be a digit, digit, and a digit. Okay. Now for digits, we have got these 6 options and repetition is not allowed. So for the very first place, we will get 6 options. For the second place, we'll get 5 options. For the third place, we'll get 26.
7, no?
Okay, sorry, it's 7. 7, then 6. We are in total got 1, 2, 3, 4, 5, 6, 7 options. Okay.
Yes.
For the first place, we got 7 options. For the second place, we got 6 options. For the third place, we got 26 alphabets
Yes, sir.
option. For the fourth place, we got 5,
5.
then 4, then 3.
3,
On calculating what we are getting from this,
65,520.
6. Option A.
65,520. That is option A.
Yes, sir.
Okay. Now we'll move to question number 8.
Sir, what do
Everyone,
we have to do? 7C1, or we have to just multiply all of them?
no, here permutation matters, so you can't use, like you can use 7 but then you have to take care of the permutation part. You have to multiply something to this. So you better not do this by combination. Okay. So you have to do just a basic question of permutation. For the first place, we have got 7 options. Then it got reduced by 1 because the repetition is not allowed. Now for the third place, we can use 26 alphabets, A to Z. That will be 26 here. Then for the fifth place, again, we have to use 1 digit out of these 7 digits. 2 is already used, so we got 5 options. Similarly, for the fifth place, we got 4 options. Now for the last place, we got 3 options. Okay. And then you have to just multiply all those. And you will get 65,520. That's the option number A. Okay.
I have to multiply all of them.
You have to
Yes.
multiply all of them. Okay. Everyone got this? Any confusion in this question?
No, sir. Sir, if we change the position of alphabets, will it make any change?
It will not make any change. Will if you increase the number of alphabet, then it will make a change. Like if you're saying we instead of place third place, we put alphabet on the second place. Simply what it will do, we will get this number of arrangement, and still we will get 6,520. But if we increase an alphabet, like instead of this place we get 8 again, then it will change the number of ways. Okay.
Sir, what if there is another position of the alphabet? What should we do, sir? Is it repetition or repetition is not allowed?
If there is another place of alphabet, then it should be given in the question that like here said no digits are repeated. If it is given no alphabets are repeated, then repetition is not allowed. If there is given the repetition of alphabet is allowed, then you have to we have to interpret that from the context of the question. It should be given the question only. Can't assume these things. Okay.
Okay, sir. Thank you.
Question.
And sir, if the condition is at first position, 0 is
Yeah.
not allowed. So the only difference we need to make, in place of 7, we need to take 6 because only 6
Yeah,
digits available.
in this place we have to take 6, and this will remain 6 only. So 0 will
Yes,
be available here. So yeah, if there was condition like 0 is not allowed at the very first place, the 7 will change to 6. Okay.
that's the only change we need to make.
Yeah, that's the only change. This is the question number 8. Okay. Consider an experiment of rolling a pair four-sided dice twice, where all possible outcomes are equally likely. Define the event A. Okay, so in what the total number of possible outcome? 1, 1,
1,
1,
2,
2,
16.
1, 3,
1,
2, 1,
6,
4. Similarly for, we'll go up to
2,
4, 1, 4,
4,
2, 4, 3, and 4, 4. So this will in total, there will be 4 rows
16,
and
sir.
4
16.
columns. Okay, 16 total outcomes.
Yes, sir.
Now they're saying the event A, first roll is result in 1. First roll result in 1, so it will include all this possibility: 1, 1, 1, 2, 1, 3, and 1, 4. Yeah, this event will include this in its sample space. Then event B, sum of two rolls is 7. So it will be 3, 4, or 4, 3. B will include only these two.
Yes, sir.
Now event C, the second roll result is 2. We get a 2 in on the second row. So that will be 1, 2, 2, 2, 3, 2, and 4, 2.
Sir, can't we take A event as a 2, 1 or 3, 1, 4, 1?
No, it's a saying, na? First roll is result in 1. First roll. It's not saying one roll result in 1. One of the roll result in 1. If say like this, one of the roll result in 1, either one of them, then we can do that. Okay. But it is saying position wise. First roll. Very first roll. So the first position roll is 1. Okay, so that's why we can't take this 4, 1, 4, 2, 4, like 4, 1, 3, 1 this. Okay, got it?
Yes, sir, but similarly, C will also be like that, right, sir? 2, 1, 2, 2, 2, 3, 2, 4.
No, it's asking for second roll result in second roll. Second position should be 2, not the first.
Okay, sir, I understood now. Thank you.
Okay. So now, which of the following statements are true? E and B are independent event.
Yes,
What
sir.
in? Yeah. Like you are saying something, somebody?
No, sir.
Okay,
That is
so
true.
let's check now. So what basically they are asking, probability of A intersection B is equal to probability of A into probability of B. Then only it will be an independent event. So what we got in A intersection B, there is no intersection. There's nothing in common in these two set.
Sir, in
Yes.
question A and C, it's asking, no?
Okay, sorry,
Event.
that's what. So A and intersection C. Okay, so that will be PA into PC.
Yes,
And
sir.
in these two events, what we have got in common? This is common. Only one is common, na?
Yes, sir. Only one in common.
So the second one, 1, 2.
1, 2, no, it's 2, 2. Okay, it's 1, 1, and it's 1, 2. So these both is common. Okay. Intersection, probability of intersection. In total, we have got 16 outcomes.
Yes, sir.
Probability, and what is the probability of A?
Oh,
That is
4
4
by
by
16.
4
16.
by 16.
1 by
And
4.
probability of C is 4 by 16. So this will be equal. This condition will hold true.
Yeah.
Yes. Yes.
So even so, first option is right. Now for the second option, just wait a second. Let me. Okay, so what do you guys understand by mutually exclusive? Anyone?
Sir, there is
A
no
intersection.
intersection between
Sir,
these pairs.
disjoint.
Is null.
Like no, these two events will never occur together. Basically, no intersection. Okay.
That the
Sir,
condition is not equal. You have
sir,
right
we
say
can say
equal
that
here.
like
Sorry. Like one at a time.
Sir, you have
so sir,
written equal here, but it's
Okay,
not equal. 1 by 16 equal to 4 by 16 to 4 by 16 is not equal.
not equal.
It is equal. 1 by 4 into 1
Hold
by
on.
4.
4.
Oh, sorry.
Okay, so what I was asking was mutually exclusive, and someone they were saying something.
so we can say that mutually exclusive mean one will not affect the outcome of other.
No, these are independent. Basically, what these both events will not happen at the same time. Mutually exclusive is this. Disjoint is zero. Only these are
Mean,
disjoints.
so means it doesn't intersect.
Yeah, basically intersection is zero, so it doesn't intersect. A, B, C.
Okay.
They have
So
no intersection.
getting head and tail in a single toss is mutually exclusive. Getting either head or tail
It
in a
is
single,
mutually exclusive and mutually exhaustive too.
yes, mutually exclusive too. Yes.
So what is the meaning of exhausting?
So mutually exhaustive means like we got what heads and tail on tossing a coin. We will get
Sir,
either
it
of
will
it
not be exhaustive, right?
like what we are talking about. We're talking about heads and tails, na?
Yes, sir, but outcome we will get only one. It will not cover the entire sample space, right?
No, it will what mutually exhaustive by you like what do you understand by mutually exhaustive?
Sir, the event, when we add up all the event, it should cover the entire sample space.
Yeah. So what's that on tossing a coin or tossing a coin? What's the sample space? This is the sample space,
Yes, sir.
and we got heads and tail. And what the mutually exhaustive basically means is like the probability of a sample space is one.
Yes.
Now, what mutually exhaustive means the probability of heads plus probability of tails should be equal to probability of S.
Yes.
It is 0.5. Again, this is 0.5. And this is
Equal to
1.
1.
So
Okay.
it will be 1. So this is mutually exhaustive.
Yes, sir.
Go-
This one is exhaust, but only one occurring at a time if you take that one I was telling.
No, that's we are talking about mutually. So obviously we can't take one at a time. We are mutually is the word for two.
So yes, the idea behind saying mutually exclusive or exhaustive,
Yeah.
or rather specifically if we talk about mutually exclusive, at least we have to consider two events. Only then you can say these two are mutually exclusive.
Yeah, we have to consider two even then only. Basically,
Yes,
exclusive and exhaustive is a relative term. So
yes,
we have to
and
consider at least two. Like it can, exhaustive can be extended to further outcomes. Like we got a let's say sample space for this dice 1, 2, 3, 4, 5, and 6. Then all these six outcomes are exhaustive. If take like then we don't say mutually exhaustive, but this P1 plus P2, all these events together are mutually exhaustive. Plus P4 plus P5 plus P6 is 1, will be 1. So when we introduce mutually exclusive, that means two 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 events have no intersection. Basically, they can't occur at the same time. And exhaustive means the probability of these two on adding the probability of these two, they will basically give the probability of sample space that will be 1. Okay. Everyone got this?
So
Yes, sir.
mutual exclusive can also be said as a disjointed set or what?
Yeah, it can say that disjoint set.
Okay.
Okay, so what they are saying, event A, B, and C are mutually exhaustive. And to satisfy this condition, we have to check A
No,
intersect.
sir, it's not satisfying.
Okay, but we have like let's solve now. No, sir, you have solve it before. That's good, but we have to solve this in the mock session. So then the cardinality of this is null. We have to prove them. If these all condition, cardinality of B intersection C and the cardinality of C intersection A is null, then cardinality of A intersection B
Yes, we
intersection
are
C.
solving for option B, is it? We did option A now.
We are solving for option B, yeah.
Oh, thank you.
So if it satisfy all of these conditions, then only it will be then option option B will be correct. So obviously this A intersection C
No,
on
but
solving the
A
first question,
intersection
intersection
C
is
is
one,
1.
no?
yeah, so it's not satisfying. That's why I'm saying if it satisfy all this question, then this will be correct. Now we are checking. Obviously in this question, on the very first option, we were getting probability of A union C is 1 by 16 and it should be 0. It is not 0, then these events are not mutually exhaustive, okay, mutually exclusive, okay. Option B is not correct.
But we are talking about all the three, but there is no intersection
Like,
between all the three.
no, if these three events are mutually exclusive, all these conditions needs to be true. Like you have studied about the independent event. If independent A and B, independent event A, B, and C are independent, then all these conditions.
See, checking for these three conditions will be sufficient, no? If any two
Yeah,
or
this
if there
will
is nothing common between two, then there can't be common between three also, no? Among three also. So checking for these three conditions will be sufficient.
we have to check this. Like as from now, it seems like this will correct. Like if there's all like between these two, there is nothing. Yeah, it will be same. Yeah. If if there's nothing in between these three conditions, it will be automatically correct. Okay.
Okay.
So basically, in conclusion, is that option B is not correct because we got the probability of A intersection C as 1 by 16, which is not equal to 0. That's why the option B is not correct. Okay.
So out of three conditions, even one condition fails also, we can consider that as a failure,
Yeah.
right?
Yeah. Now event A, B, and C are exhaustive. So let's see what's the probability of A. Let me erase few of the stuff.
1 by 4 for A.
Okay, just wait a second. Okay, so what's the
So we
probability
can
of
take that P of A equal to 4 by 16. We don't need to simplify it. It will
sorry?
help us in calculations, sir.
Sorry?
P of A equal to 4 by 16.
Yeah, we are taking P of A into 4 by 16 and P of B is 2 by 16 and probability of C is 4 by 16 again. Okay.
So the
Now we will add all these 4 by 16 plus 2 by 16 plus 4 by 16. So in total we'll get 10 by 16. It's not equal to 1. 10 by 16 is not equal to 1. These are not exhaustive events.
So what if we take 1 by 4 in P of A?
1
Is
by
it 1
it
by
will
4 in P of
when
A?
we
It
take
will be
if we
same
take
or no?
it will be same. If you take 1 by P, then what you have to
One.
do, you have to take then LCM this, you will get 16, then you have to multiply it, get divided by 4, so you have to multiply, you get 4 only. This will be equal to this. This is basic math. Yeah? This will be equal to this only.
Sir, the other way to do is this P of A, you have a set of four
Yeah, you
entries,
can
four sets. So if you add up those entries, it is not matching 4 into 4, 16 combinations, right?
Yeah,
Is that the right way? Instead of calculating, we can look at the three A union, B union, C, right? PA union, PB union, PC is supposed to be matching the sample set.
Yeah, should be like all the number, it should be matching the cardinality of sample set. Yeah. Okay.
Means taking 4 by 16 and 1 by 4 is equal, no?
Yeah, taking 4 by 16 or 1 by 4 is equal.
Okay.
Now of the last option, A given B intersection C. Let me erase all this.
Sir, it's B union C.
B union C, yeah.
Sir, can we do the fourth one with base rule?
Yeah, you can. But like why to choose long way when you have a short way? You
Okay.
can do it. Or maybe we will do it that way only. Let's see. It's given as 1 by 6. Okay, this is given to us as 1 by 6. So it will be equal to, by conditional probability, PA given B union C is equal to PA intersection B union C by P B union C.
Yes.
This is from the conditional probability rule.
Yes, sir.
Now we have got this. What is B union C? That will be B union C will be 3 by 3, 4. You will basically merge these two sets, okay?
Is it 6 by 16, sir?
Yeah, 2 by 16 plus 4 by 16.
No, basically we are not here doing the probability part. We are doing the set union. We are like basically merging these two sets. Then 1, 2, then 2, 2. We got 3, 2, then 4, 2. Okay. This is the B union C. Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
We missed one. We got, yeah. So there is in total of 6 outcomes. Now A is this one union A is 1 and 1 comma 2, 1 comma 3, and 1 comma 4. Now what the intersection part to this?
1 comma
1,
2.
2.
1 comma 2. So in total of 16 outcome we got in this set, in this subset
1.
we got 1, so 1 by 16. What's the probability of B union C? We got 6 outcome
6
here.
by 16.
6 by 16. So we'll get 1 by 6.
It is right.
It is right, okay? So this equation is right, okay? Okay, now we'll move to question number 9.
The third option is also correct, right, sir?
Third option is not correct. Sorry,
Sir, one small doubt, sir.
yeah,
Mutually exclusive means
mutually exclusive means disjoint.
That means two different. That means one is coin and one is die should be there, right, sir?
Mutually exclusive means like if you're taking a dice and a coin example, mm, see it's like you have to define some event first. Like we are taking this experiment, one tossing one coin plus rolling one dice at a time, and tossing one coin. Then what the possible set of outcomes you will get? You will get tails, then one,
Sir,
yeah, tails till six. Just wait a second. Hates one and hates till six. Now we define a event A that on the very first toss we'll get a tails. So we'll get all this outcome in this till tails six, and we divide the event B so that on very first toss we get a head. So these two events got nothing in common. So these are disjoint and mutually exclusive. Okay. And okay, now Divya, you were asking something?
yes, sir. Because B union C contains 6 elements. How it is not possible, sir? It's 5 elements. So we can't repeat 4, 3.
Where we are repeating 4, 3.
Yeah,
Where we are repeating 4, 3.
this one.
This is 4, 2. The
Oh,
last one. Okay. Okay. So now can move to.
Sir, but in the previous question, they didn't give a two conditions, right, sir? Then how can we say they are mutually exclusive?
In this question you are saying how they are saying mutually exclusive.
Yes, sir.
They have defined an event A, first role is 1, and they have defined an event B, event C, second role is 2. Okay.
Yes, sir.
Now we got this subset on for event A and this subset for event B, and we got 1/2 common here.
Yes, sir.
So obviously there is some intersection point. They are not disjoint set. So,
Okay.
so that's why they are not mutually exclusive.
sir, just show the last calculation. Wait.
Sir, do we need to take a sample space is one probability of sample space for all the conditions like
The probability of sample space is 1. This is the
yeah.
then only that set will be a sample space.
Okay, sir. For it may be either a coin or die.
Like if the probability of a set is 1, then only you define that as a sample space. Okay, for either coin and for any event, any experiment, the probability of the sample space of that event should be 1 only.
Okay.
Okay, so now we can proceed further.
Yes, sir, you can.
Yes, sir.
Okay, in this question we have got a contingency table. A manufacturer of a new fitness gadget showcased the product at a high traffic fitness expo. The following table summarizes the result for the customer who stopped to look at the innovative fitness gadget. Answer the following question. So anybody got the idea how we see the like what they're asking basically? What's association between two variables, and these both are categorical variables,
Yes, sir.
and how we calculate association between two categorical variables? By looking at the contingency table, the relative contingency table.
Yes, sir.
So we will calculate the relative. Either you can calculate the row relative or column relative. Okay. So here we will calculate the row relative frequency. So that will be what we will do. The row total we got here is
Divide
60. This is 40. This is again 40. So we divide every entry by its row total.
Yes.
For the very first box, we will get 20 by 60. that will be 0.33.
Yes, sir.
For the second row, we'll get 0.40 by
6.
60, 0.66.
0.66.
For the middle column, we got 5 by 40,
0.125.
you can write as 0.13.
Yes.
Now for 35 by 40, we got
0.875.
0.88 we can write, okay, or you can write 0.25 or
75.
0.875. Now for the last column, we got 0.25 here,
Yes, sir.
now 0.75. And when the law to find whether these two variables are associated or not is to look at the row relative frequency. Is there a significant difference? There are significant difference within the probability.
Yes, sir.
Then these two variables, gender and reaction, will be associated with each other.
So first will be the answer, sir.
First will be the answer. Okay. And a similar way, you can work out with the column relative frequency.
So we
That
didn't get it, sir.
see in the fourth week, till Q1 we studied till week 1 to week 4, and in between we studied association between two categorical variable. So for two categorical variable, basically what a categorical variable is, who are uh, uh, what a categorical variable is. Anybody?
Sir, we cannot perform numerical operation on it.
Cannot perform a numerical operation. Okay. So basically these reaction and gender, the two variables we got here, are categorical variable, gender and reaction. And to find the association between two categorical variable, what we do, we already got the contingency table. Then we have studied about row relative, and column relative frequency. That is simply you divide the each box by its row total or by its column total to find either row relative or column relative frequency. And when you do that, on doing this with every box, if you got these value, uh, 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 if these value have a have a significant difference between them, like 0.33 and 0.66, have a significant difference between them. On place of this, if we have got something like this, 0.61, 0.39, 0.59, 0.41, 0.5, 0.5, there's not significant difference between these boxes, like these values. Nah?
Yes,
So,
sir.
so these are not associated. But here we have got a significant difference between these two. That's why these are associated. Okay.
Okay, sir.
Now question number 10. Okay.
Sir, just hold on in this slide, sir.
Sir, what is meant by a scatter plot?
A scatter plot is basically this. You got this graph. You got a variable, 1, 2, 3, and some variable here which can take value from 1, 20, 100, 30. Then these tuples, like say 1, 2, like when this is the x variable, this is the y variable. When x take a value 1, y take a value 10, and you point out all such points, and you will get some the points on the graph. That's a scatter plot basically. Okay.
Okay, sir. Sir, can you find correlation coefficient?
Correlation coefficient you can find for one at numerical
Yes, sir. So
variable.
what is the conclusion for C option? Scatter plot, is it the
It's
most
not
appropriate?
scatter plot is for numerical variable. These are categorical variable. It's not appropriate for categorical variable. There's this graph you can plot.
Sir, 100% stacked bar chart if it was in option. See, then it would
Yeah,
have been correct,
yeah,
no?
yeah, it would have been correct. Bar chart can be correct, or 100% stack bar chart can be correct.
Okay.
Okay, this is basically a bar chart. For categorical variable, you can go for a bar chart. For numerical variable, you can go for the scatter
Scatter
plot.
plot.
Okay, everybody got this, and somebody asked why like we can't calculate the grading document, so the total marks is okay. So Krinapreet, this is not a general query class. This is for mock discussion session. So you can ask this our questions in general query sessions. Okay. Let me get the question now. This was question number 9, na? So we are left with question number 10, 11, and 12, and 13. So we can move to question number 10, guys.
Yes, sir. Yes.
In the question number 10, what we have got, a randomly person is picked from this group. Then what is the probability that the person is female given that the reaction is favorable? So what's the probability that the person is a female given that the reaction is favorable? So what this? That's simply PF female intersection
Favorable.
favorable
divided by P of
P of
favorable.
favorable.
P of favorable.
So we are using the base rule, right here.
No, conditional probability.
Conditional probability.
So what this? We can see here. 20 is this
Yes, sir. 20.
favorable intersection female, that those people who are female and give a favorable reaction, and total number of favorable reaction is 60.
60.
That will be 20 by 60.
Sir, is the favorable reaction happens first, sir?
The favorable reaction happen first. Like, yeah, you like for the conditional probability, what basically the rule is, whatever you got on the given side, the denominator should be there. And you can switch these two. That will be same only, the favorable intersection female. That will be same as this only, okay? But for the denominator, you must put the given condition well, okay, here.
Okay, sir. Okay, sir. I have understood. Thank you, sir.
So that will be 20 by 60, and I'm calculating this, you will get I think it's 1 by 3, 0.33. Okay. Everyone got this?
Yes, sir.
Okay. So now
Just
we'll
do it.
move to
Just do it.
Sir, is it a pure female intersection favorable is just only 20?
the P of female intersection where this is 20 and even this is 20.
Yeah. Okay,
Both
sir.
are 20.
But pure favorable, we have to consider both male and female, na, sir? Like row.
No, it's favorable intersection female. It is
Uh,
favorable. It is favorable. Then it is female too. We will get this only. The intersection part. Okay, and so got this?
Yes, sir.
Okay, somebody again was saying something. No doubt till now, na?
Yes, sir. No doubts.
no,
You can
sir.
proceed.
In this question, we have got which among the following statements are true for a variable? Mean and median will be same if the standard deviation is 0. What is standard deviation, guys?
Under
That-
root
Sorry.
of x minus x bar ka whole square.
No, that's good, but like if a standard deviation is given, like if let's say if a standard deviation is let's say 0.9, What you can interpret from this?
Sir,
Will
all the elements must be same, sir.
Yeah, must be same, but I'm just asking this question. Let's say if somebody have given you standard deviation is 0.9. Okay. So what do you mean by this? Like what can you
All
comment on this?
all data are near to mean.
See, what standard deviation and variance are the measure of dispersion. Variance. I think range even come within this range and SD. And what this standard deviation and variation give you is how much the data varies from the mean. Like we got a mean value x mean, and how much all the observation varies from this. The variation between other observation and this mean. Okay, when a standard deviation is 0, that means all the other observation doesn't varies even a little from this mean. So every single observation is same only.
Yes, sir.
So that means if a standard deviation is 0, mean and median will be same. What is mean? Mean will be
Correct,
mean of
sir.
this outcome will be 5x by 5.
Total number of outcome by number of outcome.
That will be
Sum of
5
total number of outcome.
x plus x. We have got 5x here. So x5 by 5, that will be 5x by 5. So mean will be 5 only. Mean will be x only.
Yes, sir.
And similarly, like odd the observation is same only. So whichever will be the median, that will be x only.
Yes, sir. Correct.
So if standard deviation, or even if it's given to us variance is 0, then even median will be same. Okay.
Yes, sir. Yes.
And for the second option, variance will increase by multiplying each observation of x by a constant c. So this is one of the property of variance, that on multiplying constant to every observation, variance will increase by new variance
C square. Yes.
will increase by old c square into old variance. Okay, this is the property you would have studied when you've gone through the variance. When every outcome is multiplied by c, the new variance will be c square into old variance.
Yes, sir.
So again, this we will increase by multiplying each observation of x by a constant c. Increased by, yeah, it will increase, variance will increase only. This always be a positive number only. Even if we multiply every observation with a negative constant, the c square will always be positive, so vx will increase only. Now what they're saying, range.
Sir,
Range
if C is less than 1,
if c is less than 1, still the c square will be greater than 1.
no, so for example, if C is 1 by 4, then C square is 1 by 16. So I mean, it doesn't increase in that case, no, it decreases.
If c is 1 by 4,
Then the new variance will be 1 by 16 times of the old variance.
okay, in that case it will decrease. But
Yeah.
variance will increase by multiplying each observation of x by constant c. No, it will increase only. Let's see. Okay, see, if you do this, it will even reduce your mean. It will affect your mean too.
Yes.
Then eventually this will increase only.
Sir, if
You can take
C
an
is less
example.
than, hello, sir.
Yeah.
If C is less than 1, then we are dividing the data points. So it
C
will
is less.
obviously,
Yeah, you can say you can either say we are dividing xi by 16, or we are multiplying x by 1 by 16.
yes.
So okay, or what I was saying
Sir,
that
in this question, C is considered as like constant is considered as C square, right, sir?
No.
constant is considered as c only, but in the variance formula we got new variance is equal to c square into old variance. You got it? And one doubt everybody asks me, somebody asks is,
But sir, just scroll up. Stay here.
okay, so what? Like, are you taking notes, Divya?
Yes, sir.
Okay, so like recording will be available. You can take notes. Like we can't stop for more time in between every question. You are done now. We can move.
One question.
Okay, so basically, the somebody asked if C lies between 0 to 1, then it should the variance will increase or not. So then it will decrease like when we take constant C between 0 to 1. Then the variance will decrease. Like C, if we multiply every observation by 1 by 2, then the new variance will be 1 by 4, the old variance divided by 4. So this statement will not hold correct in the who pointed this out?
Me, sir. Gaurav.
Okay, Gaurav. So you like this option will not be correct. Like if C lies between 1 to infinity, it will increase. But if it lies between 0 to 1, the variance will decrease. So this option will not hold true. Okay.
Yes, sir.
Okay. Somebody was asking another question.
So
Sir,
what is the final answer of the question?
First option is correct. Second is not. The third option we still not worked out with it. So the
option D is correct, sir. Third one is not correct because range will be increased when you increase the number of observations.
these will remain the same with increasing the number of observations.
Maybe increase, sir.
We can't determine this. What range is? Range is maximum minus minimum.
Minimum.
Range is the difference between maximum and minimum, sir. So how the number of observation will affect it?
Will remain same with increasing number of observation. When number of observation gives basically what this option is saying. Let's say for the very first we have got xn observation. Now we are introducing one new observation to the set xn plus 1. Now this the range will depend on what this observation is. So this is not universally correct. Like it may increase, it may decrease, it may remain the same. So
May
this is
increase,
wrong.
but not always.
Yeah, so this is wrong. This is wrong. That's what I'm saying. It may increase, may decrease, and it may remain the same. Okay, so
Only option A is correct.
now range x will increase with increase in the number of observation. So again, you can't say comment on this. So only option A will be correct.
So what is the meaning of standard deviation?
Standard deviation is basically the root under variance. You will have studied this.
So that is part of week 3 or week 4, I guess for
So,
Q2 it is 5 to week 8, right?
Sir, but when
See,
we are multiplying
Okay,
the
just
area,
wait. One come like say one by one. Some
sir.
like some got okay. Who was this? Divya.
Yes, sir.
Okay, Divya. Go
So the
ahead.
second option, variance will increase by multiplying each observation, no, sir. So when we are multiplying, adding
See,
it, variance will not be affected. But if we are multiplying, it will be
see,
affected, no, sir.
like see, if we are choosing a C which lie between 1 to infinity union -1.
Sir, but SAT syllabus is from week 5 to 8 only, na sir?
Yes, sir. I'm also thinking that it is from 1 to 4 week, and syllabus is from 5 to 8 week.
Yeah, it's that only. But like it's not in my hand. I've just got the mock paper and I'm just solving in front of this.
Yeah.
That's
So
not
they
in my
send it.
hands.
They're sending us a mail according to the quiz 2 syllabus.
So
But they
like
mentioned that only week 5 to 8 syllabus will be considered
yeah,
for the
whatever.
quiz
Like,
2.
but that's not in my hand. That's what I'm saying. Even if
Okay.
like as per information when I am getting, the syllabus is from week 5 to 8. But they have inserted this question from previous weeks in this mock, and I can't do anything but I have to solve this only. So okay.
Okay, sir.
So that's it. So if the okay somebody asks that the B option should be correct. So if
Yes, sir.
C lies between 1 to infinity union infinity to -1, then it will increase. But let's take you take a C between -1 to 1. Let's it 1/4. Okay. Let's take C as 1/4. Again, this is a constant. Then by this formula, new variance equal to C square into old variance, we'll get new variance equal to 1/4 into 1/4, 1/4 square into old variance. So that simply will be old variance by 16. So basically we're dividing something in by 16. So obviously new variance will be greater than old variance, will be greater than old. So in this case, the variance decreased on multiplying with a constant. So that's why option B is not correct. Okay, Divya?
Sir. Okay.
Okay, so any further doubts now?
Sir, is
So the
variance for one numerical data?
Variance, sorry.
Variance and a standard deviation for numerical data?
Yeah, it's one numerical variable. Yeah, numerical data, or you can say numerical variable.
One numerical variable, na sir. For two we need covariance, sir. Two
Covariance. For
numerical
two, we
data.
need covariance. Yes, obviously. Okay, any further doubts? So we can move ahead to question number 12, I guess.
Yes, sir.
Yes, sir.
sir, in this case, it may be increase in the option 2.
Yeah, if it was written, it may increase. The option 2 will be correct. Okay, so for option 12, we have got a drawer of socks containing 3 black, 4 blue, and 3 gray. 2 socks are chosen at random without replacement. Based on the given information, answer the following question 12 and 13. What is the probability that black pair is chosen? So in how many ways we can choose a black pair? That will be 3C2. We got 3 black socks and we have to choose 2 out of it. Right, guys? In
Sir,
how many?
10C2, sir.
3C2, correct, sir.
3C2. Like we got 3 black shoes and we need a black pair. So we have to choose 2 shoes, 2 socks out of 3. So that will be 3C2. In this many ways we can select 2 socks out of 3 black socks. And then how many ways we can choose
10C2.
2 socks out of
10C2,
these
sir.
10
10C2.
2C2. So this will be the probability for this. What's the value of this? This simply will be 3 and this
3
simply will
by
be
45, sir.
5. That will be 0.07. Okay, 0.07.
Sir, here in this question, why can't we only consider 3C2, sir?
So they're asking for probability, na? So they are asking for the number of ways. We would have done only 3C2, but they're asking for probability, number of favorable outcomes or total number of outcomes.
Yeah,
Sir,
okay,
but
sir.
total number of ways in which 2 socks can be chosen
Out
would
of 10
be
socks,
10C1 plus 9C1. because they say without replacement. So once you
No,
have
so
chosen first
like
one,
what you
Yes,
said,
sir.
what you said,
so
10C.
10C1 plus 9C1,
No, you do like why it's so?
because they say without replacement. So once you have
Okay.
picked first, you have only 9 to pick second.
No, when they are saying without replacement, that then only we do 10C2. If it was saying with replacement, then we would have done 10C1 into 10C1.
No, sir. Without replacement means, I believe this is what my understanding is. Correct me, sir. Without replacement means once you have chosen the first one, then the set remaining is 9.
Yeah, correct.
So the first one for to choose first sock, you have 10 options. So 10C1. And then
Okay.
once you have taken out first, then you are left with 9 options.
Okay.
That means it should be 10 into 9, right, sir?
Now, let me tell you where you are getting it wrong. You are saying you are taking 10C1, then after you got 9, you are choosing 9C1. Okay,
Yes,
this is
sir.
what you are saying. Now, what if we choose 10, 2 out of 10C, we got 10 socks, S1, S2, S3, S4, S5, S6, S7, S8, S9, and S10. We would directly choose 10 out. Like say we choose these two. In the next case, we choose these two. We choose these two. Obviously, we'll get two different socks only. But in the case when repetition is allowed, what they are saying, then we will choose one socks first. We will, let's say we'll choose one socks first S1. We noted it somewhere. Then we put it back. Then we'll get 10C1. Then again 10C1. So in case of
Sir,
replacement,
put it back means with replacement, no, sir.
yeah, put it back means replacement. In that case, we do
But
this.
this question is without replacement.
So that's why we are doing 10C2, na? We are choosing two, like, yeah, like, what, this
Without
question,
replacement is like repetition is allowed. That is the logic.
no, without
No, no.
replacement is repetition is not allowed.
Not allowed.
Yeah,
Okay.
not allowed. Without replacement, repetition is not allowed. Okay,
So,
let's see.
sir,
Okay, this
if
is
I've
10.
chosen
This
the
is,
first one, I have
yeah,
10 C1 ways of doing it, right? And for the
okay.
second one, my total set is 9 socks.
Like,
It
I'm
can't be
getting a
10,
point.
no?
I'm getting it can't it not getting it is not 10. I'm getting what you are saying, but it's where the concept comes simultaneously or non-simultaneous. If it is given that they are not picking up socks simultaneously, like see, if you're saying just because it is given that we have to choose two different and without replacement. What without replacement means that whatever choose, let's say we choose X as our first sock and XY as our second sock, these cannot be same. This is what you can interpret from without replacement, unless we have got two X in our set or two Y in our set. This cannot be correct.
Yes, sir.
Okay. Now, just because this condition, what we are doing, we are saying we'll choose one socks first and then I will choose another socks. Okay. But this condition will even hold true if we only choose two socks. If we choose two socks at a time, like if we choose, like in this case we will choose, let's say S1 S2 first, then S3 S in one case we'll choose S1 S2, in the another case we choose S6 S7.
Sir,
Then
but they didn't mention that in simultaneous, right, sir?
they are saying na two socks are chosen at random. They're not saying one socks, we choose one socks first and then we choose the second sock.
Okay, sir. Okay.
Two socks are chosen at random. They're bringing out two socks at the same time. It is given at the question, but if it was given like this, we first choose one sock, then we choose another sock without replacement, then you can do like this. But in this question, they are choosing two socks at a time at the same time. These are
So, sir,
simultaneous events.
what is the significance of writing without replacement?
The significance of writing without replacement is this: if it was like if the replacement was allowed, then we can't choose two socks at the same time. Okay, if the replacement are allowed, then this is what we have got as our total number of ways. Like what basically what do you mean by replacement is allowed? You choose one sock, we have got 10 socks. Yeah, we
Yes,
bring
sir.
out one socks,
And
then
then keep
apart,
it back.
then keep it back. then
Yes.
then only we had these 10 socks for then only the first sock which we choose get replaced again. Then only we have a option of 10 choices for the second socks too. So this is a case of non-simultaneous. Like we are choosing one socks first, then we are choosing the second sock. This is the case we are using 10C1 and 10C1. Here the sample space, this 10 doesn't change. But when the replacement is not allowed, we can choose two socks at a time, and so we can do 10C2 only, and it will be correct only. Okay.
What I believe, sir,
What you will? Okay. Yeah.
please allow me to say this, sir.
Yeah.
Since 10C2 also comes out 90 and 10C1 multiplied by 9C1 also comes out 90, that's why maybe we are getting the right answer. But I believe, sir, please pardon me, the right way of doing it, 10C1 into 9C1 rather than 10C2.
In any way you do, like if you even in the some other, like say if we got this 10, there we have got a combination formula. Just wait a second.
Sir?
Yeah, just wait a second. I'm just searching out a formula we got in the session.
Yeah, meanwhile, can I give my my 2 cents?
Huh?
Gaurav, actually we are taking the two
Okay.
socks in random, right? Simultaneously. Let's call the socks as S1 and S2.
Okay.
Doesn't matter whether it is S1, S2 or S2, S1. Both are same in this scenario.
Yes.
Agreed?
Yes.
So that's the case for
So
complete.
9 into 10. First time you are picking, I mean, whatever you told is correct, 9 into 10. But as both are same, right? So we are
No, it's not a
dividing it by
matter of
2.
no. So not a
Okay,
matter of both are same.
Okay, wait. Let's do this calculation. We got we have to choose two socks out of nine socks. Okay, then one way is choosing is 9C2. That will be 9 factorial by 7 factorial by 2 factorial. That will be 9 into 8 by 2. That will be 9 into
4.
4. That will be 36. Now do this 9C1 into 9C1. That will be 9 into 9. That will be 81. So obviously these
Yes, sir, here 10C2 and 10C1 into 9C1 answers are different, sir.
Sir, we can simply
wait.
choose that 3C2 into 4C2 into 5.
One by one. Okay, so the last
Sir,
one.
so we can make the question that we can choose from the 3 black shocks. Then it will be 3C2 into 4 into blue stock. Then it will be 4C2 and the gray stocks 3C2 by 10C2.
One small doubt, sir. Here, are we considering the socks or pairs?
We are considering socks or
Pairs. We are considering pairs.
no? We are considering socks only, but yeah, the question is
the pair should be same. The chosen two
yeah.
shocks should
Okay,
be same.
wait. Let me speak. Okay, so we are obviously considering socks, but the question is given the probability. We'll choose a pair of like the pair. We are choosing two socks. So whether pair is same or not, the question is saying this. Okay. Okay. Now, like Divya, you are saying something. Complete your words.
I am saying that what is the probability of the chosen stock is same color.
Yeah.
Then if we want to find it, then we have to choose जैसे सोच मैंने कोई भी दो सॉक्स चूज कर लिया इसमें से.
Okay. कोई भी दो.
हाँ कोई भी दो. तो मैं ब्लू स्टॉक ब्लैक सॉक्स से चूज कर सकता हूँ.
No, it's not a question of any the quality with the black pair is chosen.
Yeah, in the question it's given only black pair of socks.
No, I am talking about the question number 13.
Okay, so we are still at question number 12. When we got
Oh,
to 13, we will then. Okay, now another Divya, he asked a question that instead of choosing this, we should go with this way: 10C1 and 9C1. Yeah, Divya?
Sir, but both the answers are different, sir. When we calculate 10C2, we will get answer as 45. And when we calculate 10C1 into 9C1,
Yeah,
we'll get
this is not the approach, right approach. This wait a second, let me find out like
So this
how
is the
this is.
NPR, right? It is 10P2. Whatever we are doing is 10C2, or we are supposed to do 10C2 because the order is not important. SOX 1 or SOX 2 or SOX 2 or SOX 1 both are same scenario, right?
sir, move on
Yeah,
to next. It is getting complex quite.
just give me 2 minutes. Let me complete my words. Okay. Nobody will speak for 2 minutes at least now. Okay, so Divya asked this question why we didn't choose this, and I think it was Arunk who stated one point that in this case you will get importance to the first place and second place. Like on doing this way, you will give this will give a priority to the arrangement too. But in this case, the arrangement doesn't matter. That's why we are not following this way. Okay, in this case, you are saying that first place is not similar to the second place. But in this, I mean, our question, it's not like when you choose some socks first and some socks on second, it will be similar to, let's say, S2 first and S3. That will be similar to S3 and S2. That's why we have to do it this way only, 10C2, not by 10C1 into 9C1. Okay. Okay. So now,
Right, sir.
okay. Now, Divya, you got it, or you still confused with it? Or you, Divya,
The question raised by Gaurav.
who raised this question? Gaurav.
No, I got it, sir. Got it, sir. So we'll take 10C2, sir.
Okay. Like you are the one who raised that question.
Yes, sir.
Okay. Sorry. So okay. So now the question number 13 we are moving to.
So the final answer of 12.
The final answer is 3C2 by 10C2. That is 0.07. Okay.
Okay, sir. Thank you.
0.06, sir.
Okay. Whatever this calculation will get fetch you. I think on
Because
approximately
0.0666 will be continue.
666. So that's why 0.07. You approximate to one digit. That will be 0.7. But it's up to you. If you want, you can write to 0.06. They will give such interval in which these both will lie. Okay.
Okay, okay. So let's move on to the next.
Yeah, I am moving on to the next only. For the last question we got, what is the probability that they are of same color? The two socks we are choosing are of same color. And in this case, we will make cases. Case one, when both we choose are black, that will be similar to this question. That will be 3C2 by 10C2. Then case two, both are blue. That will be 4C2 by 10C2. And question three, both are gray. That will be 3C2 by 10C2. Okay. And now we have to add all these cases to get our value. The first one is 0.66, then
So it is 0.06, I think.
okay, 0.06. Then for this
Sir,
value, we have
in this question, do we need to consider All or any one of the color?
All, what do you mean by all? No, we have to consider they are saying basically of same color. Like in this question, they have said black pair. Now they are saying the pair we choose of should be of same color. So either in case one, they both can be black, they both can be blue, and both can be gray, and this will satisfy this condition. Okay, got it?
Yes, sir.
Okay, so 4C2 is in down below we'll get 45. 3C2 is 3 plus 6 plus 3. So we'll get 12 by 45 as our answer. That will be 0.27. Okay.
Yes, sir.
So here I think the last question. Okay, so I think Renu asked a doubt in starting about permutation combination. Are you here, Renu? Okay, so he's not here, so we need now. Renu, are you here? Okay, so like any further doubts regarding these questions?
No, sir.
Yes, sir, I am there.
Okay, so what doubt you asked? What permutation combination? Okay,
I asked about permutations and combinations.
permutation and combination. So say one simple example I can give you, or if you're too confused, please go with the lectures again, go through the lecture again. But one simple example is permutation is where the order matters. Like let's say we are choosing a captain and a vice captain for a team. We have got 10 players. We have to choose a captain and a vice captain. Let's say we got two players, Rohit and Rohan in this team. We're choosing Rohit as the captain and Rohan as a captain, Rohit as a vice captain. This will not be same as choosing Rohit as the captain and Rohan as the vice captain. But like what we are doing, we are making a pair, making a group of pair from 10 people. We are choosing two people. Then we are not concerned with about the position at which they are going to be chosen. Even if Rohit is chosen first and Rohan is chosen afterwards, it will be same as Rohan got chosen first and Rohit got chosen afterwards. Okay. Basically, when order matters in permutation, these are not same. When order matters, we use permutation, and combination. Basically, when it doesn't matter who comes first, who comes last, we use combination. Okay. This is the very basic meaning of permutation and combination. And if you still don't get it, I suggest you to go to the lectures once again, because um, this is the way, like this is the meaning for permutation where order matters. We use this formula, n factorial by r factorial, n factorial by n minus r factorial, na, guys? And here we use n factorial by n minus r factorial by r factorial. Got it, Renu?
Yes, sir.
Okay.
Sir, here I have a small doubt in 13th question. Last question. Here they have asked same color, right, sir? So do
Yeah,
we need to take union or intersection?
we need to take union. Like we need not to take union. Like this, we need to make cases, and we need to take for each cases we need to take intersection. Like on choosing, we get like you can't frame this as union intersection.
Like a favorable outcome, sir.
Like favorable outcome. Okay, you have to choose B black, black union black for the case one. And for case 2, it's blue intersection blue. For case 3, it will be gray intersection gray. Okay, you have to
Yeah.
choose.
That means we have to consider all three colors that are of same color socks.
Yeah,
Right, sir?
that's what it means.
Okay, thank you. Sir, is this the same pattern of quiz 2 exam, sir?
Like the pattern can be same, but I can't comment anything certain about this. But yeah, they like pattern will be same only, but I'm not certain about this. Okay.
Sir, one doubt apart from this.
Yeah.
Actually, we are in the I am in Tiruvallur districts of Tamil Nadu, but now we are facing some cyclone issue alert.
So you can.
So even I mailed the support team, but they said till now there is no change in the rate. So tomorrow is the alert of red alert has been seen due to the cyclone, and the very next day is the quiz 2. And unfortunately, I was not attending the quiz 1, so it is mandatory for me to attend the quiz 2 now. But
Okay,
the thing
so
is,
even I'm in Tamil Nadu and even I'm facing the same
yeah,
problem, and
yeah,
I can't do
yeah,
anything about this. Okay, so like you can just expect if there will be such severe condition that we can't even go to the center, they will cancel the exam.
yeah.
Or if not, like see, we have to write support. We have to go to
Yeah.
support only. I can't do anything about this. Okay.
Just I want to have that because the thing is quiz 1 if I attended I will be little bit
Yeah, like this
yeah,
is mandatory. This is what
yeah,
that
so
is,
that is
but
the
look, again, this is not in my hand. I can't do like I can't help you out here in any way.
okay,
Okay.
okay, sir.
Okay. So any further doubt regarding question?
But
So
these topics are literally confusing, sir.
which topics?
Like probability itself is
Yeah. So probability
fine.
and permutation combination is of this kind. Okay. Mhm. Mhm. Okay. This. I think we can wrap up the session now. Nobody have got any doubt regarding the mock questions. Okay. So I think will be your last TA session
So
before
what
we
you due to cyclone, the exam will be rescheduled for someone.
nothing. I can't do anything. But there is cyclone alert in Tamil Nadu, so there's nothing. There's no such news that they're rescheduling. There there are people facing problems with this, and I can't do anything. Like basically somebody asked me about this, and I don't do anything. There's no news that they are.
Just asking for the clarification because I'm in the
Yeah,
foundation level, so I
yeah,
have
yeah,
no idea about that. So
yeah.
that is the
No,
Sir,
thing I was
yeah, yeah.
having the
so
clarification.
so
It's
sir,
not
it will be
yet
rescheduled
confirmed.
for
No, no,
every
no, no
student.
such confirmation is like that. We are just
No
having
such
some
confirmation.
clarification from the
Yeah,
seniors. That's all.
yeah. Okay.
Sir, your name
The
is Pinka.
Okay, so wait, this is not a class for general discussion.
No, sir.
So
No, sir.
we should. My name is Pingaksh. Pingaksh.
Oh,
Okay,
Pingaksh. Okay, okay.
okay, and we should stop this general discussion. Anybody got a doubt with the question? Then only open your mics. Okay. Uh,
Can we leave, sir?
yeah, you can leave. I'm just like I have some work to do. I have to stop the recording and some stuff like that. You can leave. Okay, if you don't got
So,
any
sir,
doubt.
I am which doubt I want to ask that in which place we use permutation and in which place we use combination. The from practicing the question, I have gathered something that when we have to select something, then we can use combination.
Where order matters, you have to use permutation. Where order doesn't matter, you have to use combination. This simple rule, you have to extend this. You have to like this is the only rule you have to use with which by which you can decide where to use permutation and where to use combination. Okay.
Okay.
Thank you, sir.
Thank you, everyone. Best of luck for your exams. Okay, what you used to.
Thank you, sir. But we have a doubts in applying a formula, sir.
Which formula?
Law of something.
Law?
In the question we have done that, so P of C equals to P of B1 intersection C plus some.
Law of total probability, na?
Yeah,
So basically
yes, sir.
asking.
There we got confusion, sir. Where to use that formula, sir?
Law of total probability basically you have to use the formula when you have I explained this, like you got many events and like in the question we got bag B1, B2 and both bag contain cinnamon and ginger candies and we have to find the probability of choosing one cinnamon candy. So this choosing a cinnamon candy this probability of choosing a cinnamon candy lie in both of these sets, bag B1 and B2. To find the total probability of C, we have to basically do what we did. Probability of B1 given, probability of C given B1, I guess it was something like this. And probability of B2 given, probability of C given B2, okay? And if we got more such event, we got 3 bags, then we have to extend this further. There will be probability of B3 given C given B3, okay? There you should use total probability, or again if you have got doubt in this, you can go to the lectures once again because like Usha ma'am explained pretty well in the lectures. Or so this is got it, Rosni?
Yes, sir. Sir, in this formula, can we use P of B1 intersection C plus P of B2 intersection C plus P of B3 intersection C?
P of B1?
Intersection C.
I think that's the same, no? It's the same.
Yes, sir.
It's the same. It's the same.
Okay, sir. Thank you so much, sir.